Section 3.4b. Last section we talked about solving exponential equations. Now we're going to talk about logarithmic equations. This slide right here is very important to you. When you have equations involving logarithms, there are only two types of equations you could have. You could have an equation with logarithms on one side of the equation, in which you're going to follow the first set of directions, or you're going to have logarithms on both sides of the equation, in which you would follow the second set of directions. If there are logarithms only on one side of the equation, what we are going to do first is isolate the logarithm, so get the logarithmic expression all by itself. Once that logarithm is all by itself, we're then going to change to an exponential equation. Once we change it to an exponential equation, then we're just going to simply finish solving for the variable. That's it. Those are the only steps. That is when you have logarithms only on one side of the equation. If you have logarithms on both sides of the equation, we want to combine using our properties of logarithms and get a single logarithmic expression on the left side, get a single logarithmic expression on the right side. Once we do that, use another property that then allows us to set the arguments equal to one another. And once we do that, again, we are simply going to finish solving. So every logarithmic equation you see will fall into one of these two categories. Depending on which one, follow the method under each one, logarithms on one side or logarithms on both sides. Our first example here, we can see that we have logarithms only on one side. So we know we want to isolate the logarithmic expression. In this case, natural log of x is already by itself. Once we isolate it, change to an exponential. Base to the exponent equals the argument. So e to the second power equals x. In this case, x is already solved for. Go ahead and plug that into your calculator. E squared 7.389. Just like our exponential equations, you are going to give both the exact solution for x as well as the decimal approximation from the calculator. Number 5, 5 plus 2 natural log x equals 4. Logarithms are only on one side of the equation here. So I want to isolate the logarithmic expression. To do that, I'm going to start by subtracting 5. Divide by 2. Once the logarithm is isolated like we have here, now change to an exponential. Base to the exponent equals the argument. Again, plug that into your calculator to get your decimal. E raised to the negative 1/2 power, 0.607. Letter C. Once again, logarithms on one side here. 2 natural log 3x equals 4. Want to isolate the logarithmic expression, so I'm going to begin by dividing by 2. We get natural log of 3x equals 2. Once the logarithm's isolated, change to an exponential. Base to the exponent equals the argument. Finish solving that for x. We get x equals e squared divided by 3. Plug that expression into your calculator. We get 2.463. Okay, example 6. Now we're moving on to logarithms on both sides of the equation. When we have logarithms on both sides, we want to condense the logarithms on each side so I have a single logarithmic expression on the left. a single logarithmic expression on the right. In this case, on the left, we have an addition of individual logs. If I want to combine that into one logarithm, we can multiply the arguments. On the right side, to get that to a single logarithm, I know that this number out front, I can move back to the exponent of the argument. And now when we have a single logarithm equal to a single logarithm, and they are in the same base, we can take the steps and say, well, then that means the two arguments, x minus 2 times 2x minus 3 has to be equal to x squared. Remember, we had the property a couple days ago that says if we have log a is equal to log b, then that means that a has to be equal to b. Remember, that is not the same as dividing by the natural log. Remember, a logarithm, a base, and its argument are all together one thing. They cannot be separated. Property that allows us to do this is because I have a logarithm of this thing equals a logarithm of this thing. That means those two things must be equal. Now we have a quadratic equation. What do we do when we have a quadratic equation? We get everything on one side, set equal to 0, factor, or use the quadratic formula. So in this case, on the left, I need to FOIL first. We get 2x squared minus 3x minus 4x plus 6 equals x squared. Get everything on one side. Subtract that x squared over. We get x squared minus 7x plus 6 equals 0. This is factorable. Numbers that multiply to be 6 and add to be negative 7 are negative 6 and negative 1. Set each of those arguments equal to 0. The two solutions we get are 6 and 1. You need to be careful here, though. Remember, the argument of a logarithm gives us domain restrictions right away. So we need to plug each of these values in and make sure that none of the arguments are negative or 0. If they are, we know we're dealing with an extraneous root. Plug 6 in, we get 4. Plug 6 in here, 12 minus 3 is 9. Plug 6 in here, that's fine. If I put 1 in right here, we get 1 minus 2, which is negative 1. Cannot have a negative argument of a logarithm, so 6 is the only solution that works. 1 is extraneous. Letter B. Logarithms, again, are only on one side. But we know if logarithms are on one side, we need to combine that into a single logarithm so that that logarithm is isolated, so I can then change to an exponential. Well, on the left side here, I know if I have a subtraction of individual logarithms, that I can change that to a division of their arguments when we combine it into a single logarithm. Now I have a logarithm isolated. Go ahead and change to exponential form. Base to the exponent equals the argument. Solve here for x. 2 cubed is 8. Multiply the x minus 2 over to the left side. When I do that, I'm going to distribute the 8 through, so we get 8x minus 16 equals x plus 5. Finish solving for x. Subtract the x over. Add the 16 over. We get x to be 3. Check that. Make sure it doesn't make an argument negative. 3 plus 5 is 8. 3 minus 2 is 1. That solution works just fine. So our solution is x equals 3.